Humanity keeps building better telescopes. The expectation seems obvious. Better instruments should reveal more of the universe. But something else is happening at the same time. Far beyond the reach of any spacecraft, distant galaxies are moving toward a boundary they cannot return from. One by one, they cross it. Their light grows harder to receive. Their signals become harder to recover. Then the path back to them closes. The strange part is that this is not a technological failure. No broken telescope caused it. No missing observation created it. The galaxies themselves are slipping out of the future. That creates a problem no upgrade can solve. Every new telescope is designed to collect information, yet part of the universe is already removing information from the record. Future observers may inherit more advanced tools and still see less than we can see now. The familiar assumption begins to break apart. The obstacle is not how far away they are. The obstacle is that the path back to them is closing. And if entire galaxies can disappear from view, an unsettling question follows. What disappears with them? A natural response is to reach for a better instrument. If a galaxy becomes faint, build a larger telescope. If the signal becomes weak, design a more sensitive detector. That strategy works for almost every observational problem humanity has ever faced. Then the signal stops arriving. A distant galaxy approaches the cosmic horizon. Its light takes longer and longer to reach the observer. The information still exists, the galaxy still exists, but the stream of evidence becomes thinner, then thinner still. Eventually, no new light arrives at all. At that point, the problem changes completely. Nothing is being hidden. Nothing is waiting to be discovered by a future upgrade. There is simply no signal left to collect. The familiar solution collapses. A telescope can gather light that reaches it. It cannot gather light that never arrives. The consequence is brutal. Observation loses access to part of reality permanently. Future astronomy cannot recover what has already slipped beyond reach because there is nothing left to recover. The missing galaxies are not sitting in darkness, waiting for someone to look harder. From the perspective of future observers, they become functionally erased from the observable record. And if enough of that record disappears, an even larger problem begins to emerge. How much of the universe can be understood after the evidence itself is gone? There is, however, a reason to think the damage might not be fatal. Even after the distant galaxies disappears, not everything disappears with them. A future astronomer still looks up and sees a populated sky. Stars orbit. Galaxies remain visible. Large structures continue moving under their own gravity. The local galaxy group stays together instead of drifting apart. From that perspective, the universe does not appear empty. It appears organized. Observations accumulate. New surveys fill in the map. Motions repeat in predictable ways. Every measurement appears to support the same picture. The sky looks complete. Galaxies remain visible. Structures remain visible. Nothing appears broken. Nothing appears missing. An astronomer studying that universe would not feel trapped inside the ruins of a larger cosmos. The evidence seems sufficient. The map seems trustworthy. That creates a reassuring possibility. Maybe the loss of distant galaxies is not as devastating as it first appeared. Maybe enough information survives locally to reconstruct the larger picture. Maybe careful observation of the remaining structures could still reveal where the universe came from and how it developed over time. For a moment, the situation appears stable again. The universe may have become smaller to observe, but perhaps it has not become impossible to understand. If that is true, then one crucial piece of evidence should still be visible somewhere in the sky. The reassuring explanation begins to fail the moment the remaining evidence is tested. Astronomers study the sky. They map the structures they can still see. They measure motions. They compare observations. Everything appears consistent with the visible universe around them. But something crucial is missing. The galaxies that once revealed a larger cosmic pattern are gone. The vast structures that connected distant regions of space have faded from observation. The visible universe no longer presents the same clues that modern cosmology depends on today. The result is subtle at first. The observations are still real. The measurements are still accurate. The science is still being done correctly. Yet the conclusions begin drifting away from reality. An astronomer studies the sky. The measurements agree, the models agree, the observations agree. Every test points in the same direction. Nothing appears wrong. Yet every conclusion is being built from a record that has already lost part of itself. What once looked like a small surviving piece of a much bigger cosmos now looks like the entire cosmos. That changes everything. The remaining observations no longer naturally lead back to a beginning shared by all galaxies. They no longer preserve the strongest observational pillars that support modern cosmology. The chain of evidence has gaps where critical links used to be. And those links are not hidden. They are gone. A scientifically capable civilization could observe its universe with extraordinary precision, follow the evidence faithfully, and still construct the wrong cosmological history. Not because its science failed, because the universe stopped providing the evidence needed to reach the correct answer. Which raises an unsettling possibility. If future observers lose access to that evidence, what is so unusual about the moment humanity occupies right now? The evidence is still visible today. Galaxies remain spread across enormous distances. Their motions can still be measured. Large-scale cosmic structures still stretch across the observable universe. The clues exist together in the same sky at the same moment, available to be compared against one another. That condition is not permanent. As cosmic expansion continues, more distant galaxies cross beyond observational reach. More evidence disappears from the record. More of the universe becomes inaccessible. Not because nobody looked, but because the information can no longer arrive. The consequence is larger than the loss of individual galaxies. The ability to reconstruct the universe's history depends on a temporary overlap of evidence. Expansion must still be visible. Distant structures must still be visible. The traces needed to connect present observations to a larger cosmic past must still exist at the same time. Humanity happens to live inside that window. We can still see the expansion. We can still see distant galaxies. We can still compare the surviving clues against the larger structure that produced them. Future observers may possess better science than ours. They may build instruments we cannot imagine, yet they could spend their entire history searching for evidence that no longer exists. Not because it was hidden, not because it was overlooked, because the universe carried it beyond observation before they arrived. Most galaxies are already being lost from future view. And humanity exists during one of the last eras when enough of the record remains to understand what is disappearing.